Okay, so for section 11.4 area of polygons, I'm actually going to split it up into two parts because the lesson can be a little bit tedious and long. So we're going to investigate regular polygons. So a regular polygon is a polygon that has all sides congruent and all angles are congruent. Okay, so here's a regular pentagon that we see. And what we're going to do is we're going to look at if you take the center and let's say you draw from the center segments to each vertex. All of these triangles will be isosceles, and they're all congruent to each other. Picture if there was a circle going around there. So these are all the radii, and then since it's regular, we know all the sides are congruent. Okay, so that's going to be true for any regular polygon. So the idea is if we can find the area of one of those triangles, then we can figure out the area of the entire polygon. Okay, and we actually have a formula for that. Now, how do we find that? Well, first we have to figure out what are the angles in here. Well, it's a pentagon, okay, and picture it goes around all the way around the circle. So if we want to find this angle measure, then we're going to take 360 divided by 5, which ends up being 72. So this is going to be true for any regular polygon where we're going to take 360 divided by the number of sides. Okay. Now, if this is 72, so, whoops, let me just erase a little bit. So if we just investigate one triangle and say, all right, these two parts are congruent, and this is 72. If we draw the height of that triangle, that's actually going to split that 72 degrees in half. So this will be 36 and this will be 36. Now, we don't call this the height of the polygon. It's just the height of one triangle, which we're going to label as A. This is referred to as the apothem. Okay, so this is the segment drawn from the center of the polygon perpendicular to the side. So it doesn't really matter which triangle we investigate, right? If we draw the height of that triangle, that's also the apothem, and so on. So the apothem is the height of one triangle. So the apothem divides the central angle into two congruent angles. So like we saw above, when it was 72 degrees, it split it into 36 and 36. And then the idea is we have a right triangle, we can do some trigonometry if we only have one measure. So the idea is with a regular polygon, we might only have one tiny piece of information, and we have got to use either SOHCAHTOA or special right triangles to find the area of the entire thing. So below, this is, if we count how many sides, there are 1, 2, 3, 4, 5, 6, 7, 8. So this is an octagon. Okay, so just for an example, another example, if we have 8 sides, right, so our central angle is going to be 360 divided by 8, which is 45 degrees. So that's that angle. Notice the apothem is going to split that in half. So that's going to make this 22.5 and the other angle 22.5. Now picture if we wanted to find the area of one triangle. The area of one triangle would be the base, which is labeled as S, representing one side, times the apothem divided by 2. Now, how many triangles do we have? Well, it depends on how many sides, right? So in this case, we have 8 sides. So the area, so this is one triangle. If we wanted to find the total area, we'd have to multiply that by 8, right? Because we have 8 triangles. So an easier way to think of this is if I just multiplied the side by 8, that would give me the perimeter. So I'd have the perimeter times the apothem divided by 2. So that's actually the area formula that we are going to use. Now, if you have a hard time remembering that, just keep in mind you can always find the area of one triangle and multiply that by how many triangles you have in a particular shape. So if it's a pentagon, you have 5 triangles. If it's a hexagon, you have 6 triangles, and so on. Okay, so here are some steps to finding the area of a regular polygon. So what I will do is I'll walk you through the steps as we do the example. So number 1 says draw one triangle from the center to 2 consecutive vertices and find the central angle. Okay, so that first step of drawing a triangle is done for us. So I'll just kind of trace over. So here, right, we kind of highlight that one triangle. Now, also in that first step, we want to find the central angle. So in this case, we have a pentagon. So we're going to take 360 and we're going to divide by 5, which we did on the previous page for an example, and we get 72. So that means this angle is 72 degrees. Step 2. We want to draw the apothem. Okay, so step 1, just I want to highlight, find the central angle. Step 2, we're going to draw the apothem, and we're going to bisect the central angle. Okay. So as we can see, the apothem is drawn for us. So I am going to put an A here, and this is going to be 36, and this is going to be 36. Remember, the 72 is cut in half. So, using SOHCAHTOA or special right triangles, we're going to find the missing measures. So, SOHCAHTOA or special right triangles, find any missing measures. So, we have to use what is given to us since nothing else is labeled so far, right? We only have 36 degrees and we have, a right triangle inside. So we need to use the fact that it has a perimeter of 40 centimeters. So if the perimeter is 40, what is each side length? Well, it's a pentagon, right? So divide by 5, so that means each side has to be 8. So all of these sides are 8. Now we have something to work with, okay? What do we need to find? Well, we need to find 2 things. Or actually, we need to find one thing. We need to find the apothem. Now, if each side is 8, if I look at from Q to M, that would have to be half of 8. Remember, this is an isosceles triangle. So this would be 4. So now what I'm going to focus on is this half of the isosceles triangle, because I need a right triangle to use SOHCAHTOA or trigonometry. And now I have enough information. If I look at where the 36 degrees is, if I look at the 4, and I look at A, I have enough information. I'm going to use SOHCAHTOA. So in relation to 36, I have the opposite side is 4, the adjacent side is A. So that opposite and adjacent is tangent. So I'm going to have tangent of 36 equals 4 over A. That means A is equal to 4 over tangent of 36. So I'm going to divide. And I get A, and I'm going to go to the 100th place, so that will give me 5.505, so 5.51. All right. Next, it says find the perimeter, but that was already given to us, so we're good there. And then we're going to substitute the perimeter and the apothem into the area formula. So my area is the perimeter, which we said was 40 times the apothem, and we're going to divide that by 2. So 5.51 times 40 divided by 2, so we get 110.2, and these are centimeters, so square centimeters. Okay. Example 2. So now we have area of a regular hexagon with each side length 10. So each side is 10. Now it's a hexagon. So step 1 was finding the central angle. So the central angle, 360 divided by 6, which is 60. That means, what do we have? Well, if this is 60 and this is isosceles in a hexagon, this actually ends up being an equilateral triangle. Now, if this is 60, when I draw the apothem, that divides it into 30 and 30. Next, I want to focus on half of that triangle. All right, so I have this right triangle. And if this is 10, that makes this half of it, which is 5. And in this case, we don't have to use trigonometry. If this is 30 degrees and this is 90, this is a 30, 60, 90 triangle, which makes A the longer leg of a 30, 60, 90 triangle. And since the shorter leg is 5, then A has to be 5 times the square root of 3. Next, so if we think back to our steps, right? So we use special right triangles. We found the missing measure. Next, we have to find the perimeter, and then we'll substitute into the formula. Well, if each side length is 10, then the perimeter is 6 times 10, which is 60. And so now we could do the formula, which is perimeter times the apothem divided by 2. And we want to write the exact answer, and we want to approximate. So in exact form, we'll just do 60 times 5 divided by 2, or 30 times 5, so that'll be 150 times the square root of 3, or let's plug that into the calculator. We get 259.8, and that will be inches, so square inches. Okay, last example for this lesson. I want to find the area of the equilateral triangle. Write the answer exact and approximate. Okay, so central angle. Now you'll notice there's a triangle already drawn, but this here is the central angle. So if I take 360 and divide by 3, I get 120. I want to cut that angle in half, which gives us 60. That means this is 60 degrees and this is 60 degrees. That tells me this would be our apothem. We have another 30, 60, 90 triangle. But this time, what am I given? I'm given the hypotenuse, right? And the shorter leg would be my apothem. Well, what's the relationship between the shorter leg and the hypotenuse? The hypotenuse is twice the shorter leg. So that makes A equal to 6. Now I also need to find the perimeter, which means I need to know this longer leg. Well, now that the shorter leg is 6, this would be 6 times the square root of 3, which makes this entire side double that, which would be 12 root 3. Now for my perimeter will be 3 times 12 root 3, which is 36 root 3. And now I can find my area, which will be the perimeter times the apothem divided by 2. In exact form, this will be 108 times the square root of 3. In approximate form, we get 187.06, so that will be 0.1, and that's square centimeters. Now, that's not the only way to find it. If you also recognize that if I were to connect from here to here, I know that all of these have to be congruent. This would be 12. So I could just look at what's the total height. So that would be 6 plus 12, which would be 18. And I could do my traditional base times height divided by 2. We'll get the same answer.